Welcome students, welcome to class again. Today we are going to learn about vectors. In this class we are going to learn the types of addition of vectors. Before that we will revise the before class, what we have learned before. So in this class, before going to addition of vectors, we have learned about angle between two vectors. What do you mean by angle between two vectors? The angle between two vectors is the angle between tail and tail, or the angle between head and head of two vectors. The angle should be between tail and tail and between head and head. Here we can see the angle should be between tail and tail. This will be the angle of the vectors, angle between two vectors. The angle between two vectors should be in between 0 degree and 180 degree. The angle can be 0 degree and the angle can be 180 degree, but the angle should not exceed 180 degree, or the angle should not less than 0 degree. The angle should be greater than or equal to 0 degree, and the angle should be less than or equal to 180 degree. Angle between two vectors must be between 0 degree to 180 degree. Here we can see the example. The two vectors join tail to tail, and the angle between the vectors is 60 and it can be 300. But the 300 is more than 180. The angle should be less than 180 degrees, less than or equal to 180 degrees, but the angle is more than 180 degree. So this angle is not correct. This angle is correct. Now we are going to study about addition of vectors. What we are going to do in addition of vector. What are the methods to add two vectors? There are three methods. First one is head-tail method. Second one is parallelogram law of vectors. Third one is triangle method. The first one, head-tail method. What we are going to do in this head-tail method? First join first vector head with last vector tail. First join the first vector head and the last vector tail. That means this is a vector and here this is the vector. First I have to join the first vector head to last vector tail. How can I join? First I have to do a parallel shift. I am going to do a parallel shift. Then I get like this. Here is the parallel shift. Okay. Now the first vector head is joined to a second vector or last vector tail. Now how can we get the resultant? The resultant will be obtained by joining first vector tail and last vector head. Now I am going to join first vector tail and the last vector head. This will be the resultant. In this question, this is A bar, this is B bar. Now the vector is shifted this side. This is B bar, this is A bar. This will be the resultant. So the resultant will be R bar is equal to root over A bar square plus B bar square. According to Pythagoras theorem. This is according to Pythagoras theorem. The first vector head should be joined to the second vector or last vector tail. The resultant will be obtained by joining the first vector tail and last vector head. This will be the resultant. By Pythagoras theorem, we will get the resultant of both vectors. Now we are going in deep in head-tail method and we are going to do some examples. So we have learned that in head-tail method The resultant will be obtained by joining the first vector tail and the last vector head. For that, we have to rearrange the vectors in the way that the first vector head should touch the last vector tail, so that we can find the resultant by joining first vector tail and the last vector head. So there are some examples. Here we know that resultant will be obtained by joining first vector tail and the last vector head. Why did I say that the last vector? I can say that is a second vector. Why I said that will be understood by doing this example. Now, first we try to do the first example. Here is the vector. There are two vectors. First one is 4 meters north and second one is 3 meters east. Now what we have to do? Firstly, we have to rearrange the vectors in the way that the first vector head should touch the last vector tail. So I have to do a parallel shift. If I do a parallel shift, the first vector tail will touch the first vector, second vector, last vector tail will touch the first vector head. So that I am doing a parallel shift. Here is the first vector, here is the last vector. First step is this. I should rearrange the vectors that the first vector head should touch the last vector tail. After rearranging for finding the resultant will be the vector that joining the first vector tail to the last vector head. First I have to rearrange that the vectors should be like this. That means the first vector head should touch the last vector tail, and the resultant will be the first vector's tail to the last vector's head. So here is, this is 4 meters north and here is 3 meters east. Now we will find the R. R is equal to root over 4 square plus 3 square. That means 16 plus 9 gives root 25, that is 5 meters. R is 5 meters. This is when two vectors are there, we will find in this way. Here there are 3 vectors. According to the rule, we have to join the first vector tail to the last vector head. This is the resultant. We have to join first vector tail and the last vector head. So how can we find here? Here there are 2 triangles. How can we find? If the magnitude of B is known also, what is the intersecting point of the resultant on the B? We cannot find it. So what we have to do? Here also we have to shift parallelly. I am going to shift this vector here and this vector here. What happens? These 2 triangles will become one triangle. See here, the magic is here. Up to here it is A. The C will be shifted upward. Up to here it will be C. The B is shifted this side. Here we can find B. The resultant will be this. We will add this vector and this vector manually, and this will be a single vector and this will be another vector. The resultant of these 2 vectors will be the actual resultant of these 3 vectors. This is the way of finding the resultant for the 3 vectors which are arranged like this. Now we are going to another example. Here there are 4 vectors. A is the first point. The vector is traveling towards B, and from B it takes downward direction and it goes up to C, and it takes right side and it goes up to D, and it again takes downward direction up to E. The resultant, according to the rule, according to the definition, the resultant is obtained by joining first vector tail to last vector head. Now what will be the resultant of these 4 vectors? How can we find the resultant of these 4 vectors? This is very simple. Just pause the video and try yourself once. Okay. Now I will answer this question. The vector here which is present here will be parallelly shifted up to here. And the vector present here will be parallelly shifted up to here. Now we will shift these 2 vectors and we will see how the total picture looks. Here there is the point A to B. Here C to D vector is shifted here. That means here C to D. And B to C vector is shifted here. B to C. And there is D to E. D to E. Now I will join these 2 things. That is the first vector tail and last vector head. This will be the final picture of this resultant of 4 vectors. Here there is 4 meters and 4 meters. Here there is 3 meters and 3 meters. 4 plus 4 gives 8. 3 plus 3 gives 6. That means here it is 8. Here it is 6. The resultant will be R is equal to root over 4 square, 8 square plus 6 square. That gives 8 square 64, 6 square 36, R is equal to root 100, R is equal to 10. This is the resultant of these 4 vectors. R is equal to 10. This is about this question. Now we are going to know if the vectors are commutative or not. What do you mean by commutative? Commutative property gives the A bar plus B bar is equal to B bar plus A bar. Now we are going to see that A bar plus B bar is equal to B bar plus A bar or not. Now see in this figure what is happening here. Here it is B bar, it is A bar. The tails 2 are joined and it is the resultant of 2 vectors. Okay. Is it commutative or not? How can we find? I am going to shift this A bar to here. That means it comes here. B bar to here. That means it comes here. What is the resultant of these 2 bar? These 2 things. It is A bar, it is B bar. This is the resultant. Here it is the resultant. So, same resultant if we shift both the vectors parallelly. So, vectors are commutative. That is the answer for this. Vectors are commutative. Now, we are going to end this class with these challenging problems. In scalar, if we add up 2 numbers, the answer will be definitely greater than the added number. For example, 1 plus 2 definitely will be 3. 2 plus 3 definitely will be 4. 5. 2 plus 2 definitely will be 4. Other than 4, there will be no other answer. But in vectors, it is totally different. 1 plus 1, it can be 1. Or it can be 2. Or it can be any other else answer. 4 plus 3 can be 1 because of the direction. This changes is occurring because of the direction which will be for the vectors. Vector means vector has both the magnitude and as well as the direction. Now we will see one example. Here a man is traveling from the point A to B and to C and to D. He is crossing these 4 points. First he started at A and he traveled towards west direction up to 3 meters and stopped at B and he took a turn towards north and he walked straightly up to 3 meters in the north direction. After he reached the C, he took the right direction and he went up to D and it is also 3 meters east. First 3 meters west and took turn 3 meters north and took turn and 3 meters east. What is the answer? 3 plus 3 plus 3. What will be the answer? According to head-tail method, we have to join first vector tail to last vector head. We have to join first vector tail to last vector head. What is the distance between A and D? This is 3 meters. That means 3 plus 3 plus 3 is equal to 3 meters north. This is the resultant of these 3 vectors. So this kind of problems will be somewhere problematic. You have to think and give the answer to that problems. And here is the second example. A man started at point A and traveled 4 meters up to east and he stopped at B and he took a U-turn and traveling towards west and he traveled up to D, up to C. What is the resultant? According to head-tail method, you have to join tail of last vector to head of first tail of first vector to head of last vector. What is the resultant? Distance between A and C. 4 plus 3 is equal to 1. 4 plus 3 is equal to 1. This is because of the direction. So, this is difference between scalar and a vector. This kind of problems you should think and give the answer to that problem. So, in vectors, it is possible that 4 plus 3 will be 1 or any other else number according to the direction of the vector. This is all about addition of vectors, that is head-tail method. In the next class, in the next lecture, we are going to discuss about parallelogram, law of vectors. Parallelogram law of vectors. This is going to be a next class. Thank you for watching this video. Stay tuned, like, share and subscribe. Thank you for watching this video.